I hope that the presentation is visible now. And let me begin. Explainability has always been at the heart of artificial intelligence and law curriculum. The growing popularity of deep learning methods makes inquiry into deep learning explainability even more important. Moreover, it is of value not only in artificial intelligence and law, but also in general artificial intelligence research. In this work, we aim to quantify and test the usefulness of different explainability methods when applied to the area of legal text classification. Those methods were evaluated using the opinions coming from the legal professionals. This work was performed by Sashika Ramakrishna from Free University Berlin, as well as by me, and I am currently employed at the Interdisciplinary Center for Mathematical and Computational Modeling at the University of Warsaw. This talk will be structured as follows. Firstly, I will start the presentation by stating the research question, and I will also refer to our previous work to fully present the motivation before the research undertaken here. Secondly, I will talk about the computer system we have designed and implemented for our experimental explanation generation. The discussion of systems architecture will be supplemented by the review of dataset that was used. Finally, I will describe the results of the pilot study that we conducted based on the explanations generated by our system. So to begin, when the motivation is concerned, it should be noted that this work is a significant extension of our previous paper presented at the Xyla workshop during the previous Jurix conference, with extended version accepted into ICOL proceedings. In this aforementioned paper, we have presented a classification system that was based on convolutional neural network, and that system used GradCam method to highlight the most important words when doing the legal text classification. However, the choice of GradCam as an explanation method was somewhat arbitrary, and in the work presented here, we explored different methods of explanation generation for convolutional neural networks. Thus, with the work presented here, we aim to give a more structured and rigorous means of assessing different existing explainability methods. In general, there are three main categories of methods that can be employed for convolutional neural network-based explanation generation. Firstly, already mentioned GradCam is commonly used in computer vision. It uses the gradients of a target concept that flow into the final convolutional layer, and it produces a coarse localization maps that highlight the most important regions in input data that were the most important for predicting the concept. The second method that is presented here is SHAP. It is a game theoretic approach that aims to explain the output of any machine learning model, and it generates explanations using the Shapley values from game theory and their related extension. And thirdly, LIME is an example of surrogate model-based diagnostic, and it builds a local interpretable model based on the perturbation of input data fed to the model. Thus, to sum up, in our research, we wanted to uncover what lawyers think of explainable artificial intelligence systems and of the methods that can be used in those systems. The tag cloud presented on this slide comes from the survey we have circulated among legal professionals, where we asked them about their views on what features they would desire from explainable artificial intelligence-based system. Generally, they talked mainly about tools that will take the burden of manual work away from the lawyer. Many people mentioned a transparent decision process, but as will be shown later in my talk, the conceptualization of transparency varied in the opinions given by various respondents. Another thing that may be noted is that when we ask about explainable artificial intelligence, many respondents were talking about general artificial intelligence system. Thus, they were viewing those two terms as, in a way, synonymous. And in conclusion, we may say that explainability for a lawyer is a crucial feature of the system, and it is indispensable in their mind. And it is a necessary element of any artificial intelligence-based system for law that can be used by the lawyers. Moving on to the methodology, we have built a modular system. In its heart, it has a convolutional neural network, like here. The implementation of the networks that we have used was sourced from an external authors and used with their permission. We have used the system developed by Hebin Shin, which was based on theoretical insights from Yoon Kim. Our core contributions to the system is the extension of the embedding module to support various embeddings, like what2vec or BERT. Secondly, we have introduced artificial intelligence and law-based datasets to the system. And thirdly, we have added pre-processing tools as well as a metric comparison module. This metric comparison module is based on the insights from computer vision and uses a well-known set of metrics to generate insights into how the system works. In the experiments that we present here, the convolutional network was trained on the PTSD dataset. For testing purposes, we allow a user to choose a variety of embeddings. However, in this research, we have settled down on using distribute-based embeddings. Though other versions of the systems I have already set allow to choose another set of embeddings. The part that will be crucial in this presentation is the fact that the CNN module was coupled with the visualization module, which generates heatmaps that show the most important words that impact the classification of the convolutional network. For this paper, we have explored how can the visualization module be extended to accommodate different kinds of explanation generation methods. In addition to GradCam, what came out of the box in the CNN implementation that we have sourced, we have coded a sharp and line explanation generation module. In the remainder of this presentation, we will focus on those additions and how they were assessed by the evaluation group that consisted of professional lawyers. As for the dataset used, as already mentioned, we have settled down on using the well-known PTSD dataset. It is a collection of 50 judgments coming from the US Board of Veteran Appeals. Each sentence of those judgments was annotated by human annotators according to the rhetorical role that those sentences play in the judgments. There were 6 roles distinguished, and the exemplary sentences are shown at the bottom of the slide. Our convolutional network was trained on this set, and we achieved relatively good accuracy of about 83%. Though we really did not focus on the efficiency of the classification task, as our main aim was user-based evaluation. Nevertheless, we conclude that those results in terms of accuracy are already satisfactory, and we believe that they can be improved down the line when more work is put in this area. The most important part for this presentation was the fact that the network was used to generate explanations in the form of heat maps, as presented here on the slide. Each explanation method generated a distinctive set of heat maps. We have chosen 6 sentences from the PTSD test set that were correctly classified by the network, and explanations were generated for each of those sentence types. Like 3 explanations were generated, each for GradCam, Sharp, and Line. To assess the usefulness of those explanations, we have prepared a survey which was circulated among legal professionals. They were instructed that the computer mark the parts of the sentences which were the most decisive for making a decision regarding the classification. The lawyers were then subsequently asked to grade each of the explanations on a scale 0 to 10, with 0 being worst and 10 being the best. The slide that is presented now presents an overview of the results for a sample sentence. Next to the sentence's heat map, we present the average user score as well as the resulting, and we have also assessed the explanations in terms of the metric that comes from a computer vision. In the paper, we give a set of 2 metrics. Here, for this slide, we show the metric which in full is called fraction of elements of relative threshold, and this metric represents what portion of input data was taken into account by the CNN. It can be clearly seen that SHAP highlighted the whole sentence, while GradCam was the most selective method. So there were differences in our respondents' assessment of various methods. Statistical analysis shows that those differences were not statistically important. Therefore, it can be said that all the methods were assessed by our respondents similarly. And when deciding what method to use in a computer system, other factors should be taken into account. For example, from a software engineering point of view, it should be noted that implementation of certain method is dependent not only on user's voice, but also on technical feasibility. GradCam is a method that, to the best of our knowledge, works only with convolutional networks. LIME is a method that is dependent on a number of hyperparameter values, and there are papers that suggest that it can be tweaked to the point of showing anything that the programmer wants. As well as the technical merit is concerned, we have used open source libraries for implementation of different methods and have found that the quality of implementation is varying. Thus, this may also be a factor that can be taken into account. And finally, let me make some additional remarks. Let's return to the example that was shown on the previous slide. Here, it can be spotted the results between different explainable artificial intelligence methods vary widely. For example, when I have seen the results coming from SHAP, my first comment was that it has gone ballistic. Yet, there was a disagreement between the respondents, and 8 of them said that the results for the citation sentence given by the SHAP were the best, while 9 experts have graded it as the worst. Thus, there seemed to be an implicit disagreement between different respondents as what exactly is the best explanation. This can be further strengthened by different comments that we have received from the respondents after performing the survey. For example, one of the respondents has said that he did not do this part of the survey at all because he was confused by what those colorful words were supposed to mean. On the other hand, the other expert has said that it made him question how he thinks as a lawyer, because this classification task is something that he would do intuitively. He had implicit mental model of the task, and our survey made him question how that implicit mental model really works. In addition to the part that I have already shown, the lawyers will also ask a number of generic questions regarding their stance towards the artificial intelligence in general, as well as its usefulness in their professional life. This part was meant to elicit the requirements for such systems as provided by the respective users. The prospective users, the legal experts, were asked generic questions regarding artificial intelligence and explainable artificial intelligence, and we have also allowed them to freely write what they expect from AI-based systems in terms of justification. As far as the results go, we have in general found the lawyers to be enthusiastic towards the use of artificial intelligence in law. The tech cloud, which was already presented in one of the previous slides, showed the phrases that occurred in the answer most often. Artificial intelligence and law curriculum seems to have penetrated the ranks of the lawyers, as 90% of the respondents see them as useful. Remaining 10% had no opinion, and they were not negative towards the AI-based system. 62% of the respondents had acknowledged that they were already acquainted with the term explainable artificial intelligence. And 52% of the respondents believe that one has to understand the inner workings of the explainable system to receive meaningful explanation, which suggests that understandable explanation that do not that allow one to understand the system's decision without knowing its inner workings is something that needs to be worked on. This concludes my presentation. We consider that the work presented here can be a basis for deeper studies. We had 21 respondents, and obviously future work should include a larger user base. Explanations can be tested using different datasets and other visualization methods, and a more in-depth studies of lawyers' conceptualization of explanation should also be conducted. Most importantly, we think that means of introducing domain knowledge to the explanation should also be explored. Thank you for your attention.
Thank you, Łukasz. And now we have a few questions from the audience. The first one, course stacking. The author of asks this. The authors of SHAP show in their NIPS paper that LIME is basically a subset of SHAP without the guarantee of accuracy and consistency. The only advantage that I know of is that LIME is just sometimes faster. So why use both SHAP and LIME in your explanation model?
Yes, I agree that LIME can be thought as a subset of SHAP in a way that both of them are based on generating local explainable models. In my opinion, for the full overview, both of those methods should nevertheless be compared. I mean, if there is a method that is commonly used, and to my knowledge, LIME is such a method that I think that omitting it would be an omission in this paper. I don't know, would Sashi like to comment on this question as well?
No, I think you pointed it right, Łukasz. So because LIME is also one of the commonly used methods, right? So we did not want to leave out of the comparison chat that we had, and we did understand that LIME and there's not greater difference between LIME and SHAP. They both originate from a similar principle.
Okay, so can move on to second question from Trevor Bench Kaplan. All words highlighted got a score of nearly 5 to 10. This suggests that the users were rather undermating. Would no words highlighted also get 5 to 10? After, I think the third question will be easy. And from Sabine Weinhardt, how large was the pilot?
I think I should have mentioned that in the conclusion, it was 21 respondents. Yes. And as far as the second question go, the scores of about 5 out of 10 that I have shown on the slides were the averages that we have received. And we have found that the users, when concrete answers by concrete users were explored, they were much more divided regarding their assessment. So the people tended to give high score to certain methods in certain explanations and low scores to other ones. So that 5 out of 10 is just an effect of averaging that was presented here in the results. Thus, based on the individual answers, I can speculate that no what's highlighted would be graded as zeros by the respondents. But this kind of control sample might be good to be added in future studies to see whether they really give it a score of 0.
So I have another question here. Is it possible to notice that lawyers who are not used to the concept of AI and participate in the survey got more enthusiastic or somehow disappointed with AI in your point of view? Which were their expectations when hear about AI?
The answers that that we got, I mean, I can make the conclusion based on the answers that we got, and the answers we got were generally that they were enthusiastic towards the artificial intelligence, and 90% of them has shown that that they see the use of such systems. And many of the lawyers have also said that they were knowledgeable of the term explainable artificial intelligence. And I must personally say that I was a little surprised with the results. In general, as I have already said, they were enthusiastic towards the artificial intelligence and have seen this as a method that will take away the burden of manual work from them. But I think that this is something that every professional group may expect from artificial intelligence.
Okay, and I have another question from Trevor. How can every word highlighted explain anything?
I completely agree with that comment. As I have said, when I have seen the explanation given by Sharp, my conclusion was that it is useless. Nevertheless, many of the lawyers have highlighted this as the most important. I think that this shows how the concept of transparency and explanation differs between different particular lawyers. So a more detailed inquiry should be made. A more detailed inquiry should be made to test what lawyers really want from such an explanation. My hypothesis was that in case of the explanation that marked all the words, the 8 lawyers that said that it was the best explanation wanted the most complete set of words from a given sentence. Like for the citation amounted not only to the reference to a judgment that was cited there, but also the summary of the points that were coming from the judgments. And maybe for those lawyers, only that offered a complete explanation of what the system did. At least that's my hypothesis, and as I have already said, this deserves further inquiry.
And another question from Malte Ostendorf. Did you see any difference how useful the explanations were given, a correct wrong prediction from the model?
The short answer is no, and the longer answer would be that we did not test that. When we presented the explanations to the lawyers, we took only the ones that were correct, because we thought that the incorrect ones may be somehow confusing to the lawyers, and this is something that might be explored in the future work. Thank you for your compliments. And of course, the question that you have asked touches the heart of what I think the artificial intelligence and law tries to do. Whether that is possible Maybe let me go back to the survey that we have performed. And the lawyers there, when we analyze the answers that they have given, it can be seen that they had hopes that the artificial intelligence will take away the burden of manual work from them. They did not talk about doing things that involve creativity or very deep analysis of facts or evidence. And obviously, this is something that needs a lot of work to go. For the time being, I think I think that this artificial intelligence law tools can be used as in a supporting role, and the hardest cases will be something that has to be left out for the human. Also, I have talked about this with my co-author yesterday, and maybe Sashi would like to make a few additional remarks.
Hey, hi. I guess this is Shashi.
Hello.
Yes. So this is a two-part answer. The first part is will the explainable system completely replace a judge's argumentation scheme or a lawyer's argumentation scheme? We are not yet there. At least that's the result that we gave or heard back from the surveyors. But what they want to see is their day-to-day mundane tasks being automatized, and that is so their notion about an explainable AI system is something that helps them to complete their day-to-day process, but still allows them a large scope of adding pragmatics to it, right? So it can help them to understand the semantics around it and get the work done, but they still think that the lawyers needs to be there to add the pragmatic layer to it and actually make some decisions or generate arguments out of it.
Okay, thank you, Lucas. Thank you, Sashi. And we also have another question made by Jack Conrad. What would you say if someone observed that this work is already somewhat outdated, since current modeling has moved beyond CNNs to more complex models whose networks involve millions of parameters and magnitudes, more training data, which would challenge any means to visualize the attention of the system's inferencing and decision-making?
As far as the answer to this question go, I will also say that this answer should consist of two parts. One is the realization that, of course, there have been more complex models, and the people have really went away from CNNs to more complex solutions in their work, and so this is something that one has to agree with. However, when one is considering those three methods that we have tested in this work, it should be noted that, as far as I am aware, there were not many papers that have compared those three methods. I am unaware of any paper that have done very deep comparisons, or the ones that are domain specific, like target the domain of law, as it is in our case. The Gratka method that we have used works only with CNN, and this is something that someone who implements a system should have in the back of his head, that if one does not use CNN, the Gratkams is not useful. I can't give a conclusive answer regarding the LIME or SHAP, but as far as I am aware, those methods are supposed to work with any systems. So I think that they could be used with systems that would use something else than CNN, but it is something that we should look into to give a definitive answer.
Sashi, you want to say something about it?
Hey, sorry, I was on mute. Yes, a little bit. So what we were trying to understand here, yes, there are many methods, the complex models are there beyond the CNN, right? But the variations in the results, that means that, when you consider a small paragraph at hand, certain methods would mark only one or two words inside the paragraph, marking them important. Some methods would mark the entire paragraph, that means important. So when you're looking at the complete spectrum, that is when you're trying to understand what is the perspective of a lawyer who's viewing it. Does he think that the entire paragraph is I mean, we're talking about the mental model of a lawyer. Does he think the entire paragraph is important when you actually talk about an explanation? Or do you think only few words are important? So this was also a very important aspect that we tried in. Like Jack said, right? I mean, we still have to again figure out what are the other newer models that could be incorporated, and the same experiments can be run again on those models also.